Good morning, everybody. Under magnetic effect of electric current, today we are going to study electric generator, another important device to understand. Here you observe what is alternating current, short form AC. Similarly, what is direct current, short form DC. And as you know already, so in previous class you have studied Fleming's right hand rule. Once again I repeat, Fleming's right hand rule. Right hand rule. Fleming's right hand rule. Fleming's right hand rule. You have studied yesterday, same we going to repeat. And so in generator, electric generator, so we have used Fleming's right hand rule. Okay, so first we start with the, as you know, principle. Okay, so first you have to understand here principle of electric generator. Okay, principle of electric generator. Second here construction, and third part here working rule. Okay, working rule. Okay, so very important, working rule. Principle, construction, working rule. These three aspects you are going to see in this as a concept. Okay. First, electric generator. Principle. Electric generator is a device in which mechanical energy converted into electrical energy. Here in this construction, electric generator. Okay. So draw the neat labeled diagram of electric generator. Draw the neat labeled diagram of electric generator. Okay. So here drawing. Simple drawing and labeled parts. Okay, here we can take powerful magnets, powerful magnets, brushes, rings, galvanometer, okay, axle, external circuit, like this, external circuit. Okay, external circuit. External circuit like this. First here, principle. So very simple here in this structure, as you know already, mechanical energy converted into, as you know, electrical energy. The presence of electricity in the coil we detect by, as you know, galvanometer. Mechanical energy converted into electrical energy. Mechanical energy converted into electrical energy. Okay, so ABCD rectangular coil is moving in between powerful magnets. Means it is moving. Coil is moving. Rectangular coil is moving in. Rectangular coil is moving in magnetic field. Magnetic field generated by two powerful magnets here, N and S. North pole, south pole. Okay, so electricity produced. That production of the electricity we detect by galvanometer. That is the basic idea to understand. Okay, principle here mechanical. In electric generator, principle is mechanical energy is converted into electrical energy. Electric generator, the term itself indicates electric generator generates electricity. How? By mechanical energy. Electric generator generates electricity by mechanical energy. Okay, that one you have to remember. And second part here, construction. Okay, construction. If you see here construction, so all the parts you have to understand. Okay, how they are assembled. When very important. As I told here, so ABCD rectangular in shape, rectangular coil, okay, coil, insulated copper wire wrapped to a rectangular soft iron core. That is ABCD rectangular coil mounted in between two powerful magnets, N and S. And as you have seen, this is axle. In axle we observe R1 and R2 slip rings, slip rings, R1 and R2 slip rings. Okay, so these rings are insulated inside. These rings are insulated inside and attached to the, as you know, axle. Insulated inside. Okay, attached to the axle, and R1 and R2 rings are internally connected to the axle, which is moving armature. R1 and R2, both the rings are internally connected to the axle, which is moving part of this, as you know, armature. That is axle. You need to understand. And B1, this is B1 and B2 are carbon brushes. Okay, B1, B2 are brushes. Okay, which as you know touch the armature, touch the moving part. B1 touching upward and B2 touching downward while moving the coil, moving the armature. It is a conducting brushes. They are conducting brushes. B1, B2 are conducting brushes. B1, B2 are conducting brushes. R1, R2 are, as you know, slip rings which are internally connected to the axle. So then, external circuit, what we see here from B1 to galvanometer, once again B2 to galvanometer. External circuit, so connected with the galvanometer. Galvanometer detect the presence of electric current in the coil, ABCD rectangular coil. Galvanometer recognize, galvanometer identify the presence of or generated in electromotive force or generated current or induced EMF in the ABCD rectangular coil. Okay, so these are the parts relating to, as you know, electric generator, or what we say, construction of electric generator. Construction of electric generator. And third here, working role. How it is working? How electric generator working? How electric generator produce electricity? Okay, you need to understand how electric generator produce, as you know, electricity. As I told earlier, under principle, as I told earlier, so mechanical energy converts into, as you know, electric energy. Mechanical energy. Electric generator is a device in which mechanical energy converts into electrical energy. Mechanical energy converts into electrical energy. Electric generator generates electricity. Okay, so which principle, which as you know, rule we are using here, as I written here, Fleming's right hand rule. Fleming's right hand rule we are applying. Okay, so to generate electricity by electric generator, you have to focus on Fleming's right hand rule. You are taking your right hand. And stretch first three fingers perpendicular to each other. You are taking right hand, stretch first three fingers perpendicular to each other. Thumb, forefinger and middle finger. Thumb shows the direction of motion of the conductor. Forefinger shows direction of magnetic field. Then middle finger shows direction of flow of current generated in the coil. Once again I repeat, state Fleming's right hand rule. Statement. We are taking our right hand, first three fingers, thumb, forefinger and middle finger we stretch perpendicular to each other. All three fingers are perpendicular to each other. Then thumb points the direction of movement of conductor. Forefinger points the direction of magnetic field. Then middle finger shows the direction of flow of current. Okay, so this is nothing but statement of Fleming's right hand rule. Fleming's right hand rule is used in electric generator. So last part here, working. how it is working, very important to understand. So now start here. As I informed earlier, so here this part, as you know, ABCD rectangular coil mounted in between N and S powerful magnets. Powerful magnets produce magnetic field. Powerful magnets produce powerful magnetic field. In powerful magnetic field, magnetic lines of forces are present, in which ABCD coil starts to move. Understood? No? This is very important. In magnetic lines of force, in magnetic field, ABCD rectangular coil starts to move. Okay, starts to move because of force, magnetic force. So here, when AB is coming up, AB is coming up, AB edge of the rectangular ABCD coil coming up, then CD getting down. AB is coming up, CD getting down. If one part, suppose this is rectangular, okay, so rectangular coil. Suppose AB edge, if you see here AB edge. AB edge coming up, naturally another CD edge getting down. So AB edge coming up, then CD edge getting down. So likewise AB getting down, then CD edge coming up. Okay, so like that AB coming up, CD getting down. AB getting down, CD coming up. Like that, clockwise this, as you know, rectangular coil moving. You need to understand clockwise. So when AB edge of the rectangular coil coming up, CD edge getting down. Okay. So in this case, what we need to understand here is, okay, very important. Just observe here. So when AB is, as you know, AB edge of the rectangular coil coming up, CD edge getting down. In this case, current flow in this direction, B2 to B1. Okay, first half cycle. What you need to understand? First half cycle. So current is flowing from B22. See here, B2 to galvanometer, then B1. B2. This is B2. Brush 2 to brush 1. B2 to B1. Okay, this one you have to understand. B2 to B1. Current generated in the coil moving from B2 here, B2 to B1. That is important to understand. And the direction of flow of current in the rectangular coil is ABCD. Okay, direction of flow of current, generated current in rectangular coil is ABCD direction. That is about first half cycle. Okay, first half cycle means you know. So they just like semicircle. So 180 degree. So this rectangular coil moving about 180 degree only. 180 degree. Half of 360 degree. 360 degree means complete one cycle. This is like semicircle. Half cycle. Okay, 180 degree. Up to here it is moving. Okay. So we tell first half cycle. Up to 180 degree only. Then flow of current in ABCD direction. ABCD direction. Here in external circuit, current is moving here ABCD, D to B2, B2 to galvanometer to B1, B2 to B1. Okay, so B2 brush to B1, the direction of flow of generated current in the coil moving B2 to B1. If you come to second half cycle, it won't stop like that. Second half cycle. Second half cycle. Second half cycle, what will happen? Okay, so first half cycle, AB came up, CD getting down. So it is moving clockwise direction. This ABCD rectangular coil moving clockwise direction. Similarly, in second half, as you know, CD coming up, CD edge coming up and AB edge getting down. CD edge, as you know, coming up and CD edge coming up and AB edge getting down. Okay, so then direction of flow of current, as you know already. So here B1 to B2. Direction of flow of current B1 to B2. In reverse. Here B2 to B1. Here B1 to B2. Why? Instead of AB, here we get here CD. Instead of AB, we get here CD. Instead of CD, we get here AB. AB. CD. Now CD come in contact with B1. And the AB edge of the rectangular coil come in contact with B2. Now direction of flow of current is B1 to B2. Reverse like this reverse. B1 to B2. B1 carbon brush to as you know B2. Similarly in the coil you can see instead of going like this, it is reversing now. Okay. Or here you can see now DCBA. Direction of flow of generated current is DCBA. DCBA. You can see here DCBA. DCBA. Direction of flow of current. Reversal. Okay. Earlier in first half cycle, direction of flow of generated current in the coil ABCD. ABCD. Now second half cycle means once again like this. Okay. Second half cycle once again 180 degree here. The first half cycle. Here second half cycle, total complete one cycle. Complete one cycle. Okay, complete one cycle. Okay, so first half cycle, here second half cycle. If you combine first and second, it's a complete one cycle. Movement about 360 degree. Rectangular coil moving about 360 degree. What you need to understand? Okay, in second half cycle, the generated current in the coil in the magnetic field, powerful magnetic field, moving in the direction B1 to B2. B1 to B2. Here, okay, B1 to galvanometer once again to B2. What you need to understand? The direction of flow of current here in the rectangular coil. What direction? DCBA. DCBA direction. So like this you have to understand. So if you bifurcate first half cycle and second half cycle, very easily you understand the working rule of functioning of as you know electric generator. One thing you have to remember. And once again I am repeating here, Fleming's right hand rule is used. Fleming's right hand rule is applied. You have to understand. So what is the speciality here in electric generator? As we know, mechanical energy converted into as you know electrical energy. Electrical generator generates electricity. That can be detected by galvanometer in the external circuit. Very important. By first half cycle and second half cycle, what we need to understand? So for each half cycle, current is reversing. Current, generated current is reversing. Okay, what you need to understand? Reversing. Okay, so generated current for every half cycle, periodically, for particular period, particular time limit, it is reversing. Okay, so you know in first half cycle, generated current moving B2 to B1, as I informed, B2 to as you know B1. In second case, B1 to B2, reverse, B1 to B2. First case, a rectangular coil, flow of current direction ABCD. Now DCBA. Okay, in all aspects, periodically the generated current in the rectangular coil ABCD reverses. Okay, this reversing of generated current in electric generator is called alternate current. Okay, alternate current. Short form we write AC. Short form alternate current. Alternate current is nothing but AC. Short form. Okay, AC. Current alternates for every half cycle in a electric generator periodically. So that is called as you know alternating current. Normally in all as you know domestic purpose in industry we are using alternating current. Only in laboratory, okay, to conduct experiments, okay, science experiments, we are using direct current. We will see what is direct current. So in all domestic purpose, okay, institutions, schools, colleges, home, shopping complex, every hotels, restaurants, we are using alternate current. Okay, so this is very important to understand. Here, another aspect we need to understand. In India, for example, in India, so alternating current range normally 220 volts. Okay, in India 220 volts. Alternating current range in India 220 volts. Sometime more than 220 volts enter the system circuit. Sometime less than 220 volts enter our system building or circuit. Okay, you should note this point. Okay, in India 220 is a limit to function almost all electrical devices. Okay, so very important to understand. After alternating current, so by this device we can understand alternating current AC we have studied AC. How current alternates for every half cycle. After that, how to understand as you know direct current. Direct current. Okay, this is very important. Okay, direct current AC. Alternate current as I told for every half cycle current alternates. Okay, first direction of generated current B2 to B1. In second case, second half cycle B1 to B2. First half cycle, the flow of current in ABCD coil is ABCD direction. In second half cycle, DCBA direction. For every half cycle, generated current in the coil ABCD in the magnetic field alternates. So it is known as alternating current. Short form AC, alternating current. Okay, domestic purpose we use alternating current AC. Okay, so it is alternating for 1/100th of second. Okay, 1/100th of second current alternates. 1/100th of second, 100, one part out of 100. 1/100th of second current alternates. The frequency, okay, the frequency of current at AC is 50 Hertz. Frequency of alternating current is 50 Hertz. 50 Hertz. Okay, this is very important to understand. And when compared to direct current, okay, what is the advantage of alternating current? When compared to direct current, what is the main advantage of alternating current in our system, in our country? Okay, after generating, as you know, alternating current in powerhouse. After producing alternating current in powerhouse, we can transmit alternating current for a longer distance. We can supply the generated electric current, alternating current for a longer distance. Okay, so without loss of much energy, we can transmit to longer area. As I informed in electricity also, after generating electricity means alternating current in the powerhouses, we have interstate grid. One state to another state we send. One district to another district. Inter-district grid of the electric, as you know, system. And inter-talo village, remote area also we send. Okay, so one state sending excess of means transmitting. One state after production of alternating current periodically in the powerhouse, it is transmitting excess current to another state. Particular state is lacking the current. Okay, particular state. Okay, state which is lacking the current gain electricity from neighbor state. So we have interstate grid by which we can supply generated electricity, we can transmit generated electricity in the electric generator for a longer distance without much loss of energy. That is the main advantage of AC when compared with respect to DC, direct current. How we generate direct current in this electric generator? How can we generate? Device is same, but small alteration we have to do. Okay, small alteration. What we used to do here, R1, R2. Here we use instead of slip rings, we use here split rings. Okay, R1, R2, two rings. Here split rings we use. Split rings we use. Split rings, as you studied in electric motor, split rings are there. One ring, okay, one metal ring which is fixed here, one metal ring made into two equal halves. Two equal halves. 1, 2. Two equal halves and here fixed to the axle. It is a rotating part of the armature. Rotating part of the armature. Armature means moving part, moving spare part of the electric generator. Armature means axle with respect to, as you know, ABCD rectangular kind. Together we call armature. Armature, moving part, like arm. How arm is moving, flexible in our body. Same time armature is moving. Okay, remember axle, either slip rings or split rings. Together ABCD rectangular coil we call armature. Armature means rotating part in the machine, in the system. Here in electric generator. In electric motor, previously you have studied. So one full metal ring split into two equal halves fixed here to the armature, to the axle. Split rings acts as a commutator. Split rings acts as a commutator. Okay, so these two brushes, you know, B1 and B2. B1 and B2. You can see B1, B2. Here and here. B1 and B2 are conducting brushes. B1 touching the moving coil upward. B2 touching moving coil downward. They are touching, pressing, by which generated electricity, induced EMF flowing through the circuit, by which galvanometer recognizes. B1 and B2 are conducting brushes. They press the moving armature, moving axle, moving ring. It may be slip ring or split ring, by which what happens? Generated electricity in the coil passing through the external circuit. Galvanometer detect how much electricity has generated. Normally in laboratory, very minimum quantity of electricity we generate. Very important points to know. Minimum quantity of electricity we generate and LED bulbs let off. Okay, but for our purpose, okay, it may be Taluk, district or state or the country, large quantity of electricity we need. Large quantity of electric energy. So we depend on powerhouse. Power means production of electricity. Okay, production of electricity in a system, powerhouse, in a particular place. Okay, so here powerful strong magnets we keep. In between them we mount big rectangular coil. As I told, number of turns we increase. Number of turns, okay, copper wire we increase. If we increase number of turns, if we increase magnetic field, then in between powerful magnets, if coil is moving very fast, enormous amount of energy, electric energy generated. Large quantity of electricity generated. So large quantity of electric energy we can transmit to various remote areas of the country, state, okay, district, very important. Large quantity of alternate current we can send it to remote areas of the state or country. So this is the technique. Okay, so normally in electric generator model we generate little quantity of electric energy just to study, but really, okay, in real life we need large amount of energy for use of course of people. Okay, so we have powerful magnets and number of turns are more, okay, in the ABCD rectangular coil. So we generate enormous energy, we transmit to remote areas of the country. That is called powerhouse. The place in which we generate electric energy is called powerhouse. The place in which we generate electricity is called powerhouse. Various places we generate electric energy. Okay, very important to understand. So R1, R2 split rings we have here. Okay, so split rings are acting as commutator. Okay, commutator is reversing current for first half cycle and second half cycle. Commutator do very good job. Okay, for first half cycle, if for example, as you know, flow of current is, as you know, B2 to B1 direction, first half cycle, if you see first half cycle, direction of flow of current B2 to B1, for example, B2 to B1, B2 to B1, brush 2 to brush 1, Okay, conducting brushes. In second half cycle also. In second half cycle, if you see second half cycle also B2 to B1. Okay, see speciality here. You can compare with respect to first half cycle, second half cycle of AC, alternating current. In DC, what direct current, what will happen in this generator? Small alteration we do. Okay, so split rings we adapt here, split rings we fix here, inbuilt, and as you know, system is same, no change. So R1 and R2 rings acts as a commutator reversing the current. Okay, and every time for first half cycle and second half cycle, reversed current commutator allowed to move in same direction. Commutator allowed to move in the same direction in a circuit. Okay, so this is the unique behavior of the commutator. Okay, so here first half cycle generated current flow in the B2 to B1, B2 to, as you know, B1. In second half cycle also generated current flow in the direction of B2 to B1. Okay, whatever it may be the direction of ABCD coil while moving clockwise. Okay, if ABCD coil is moving, armature is moving about 180, total 360 degree, complete cycle, whatever it may be the movement of the, as you know, ABCD coil, whatever it may be the direction in clockwise direction. Okay, so or anti-clockwise direction. Normally we consider here say clockwise direction. Okay, ABCD is moving here in clockwise direction. Then, so generated current in both the cycle, first half cycle and second half cycle, moving in same direction. Okay, so it is known as if generated electricity is moving in same direction for first and second half cycle, for first half cycle and second half cycle, then it is known as direct current. What is the meaning of direct current? The generated current in the coil in electric generator for first half cycle and also second half cycle moving in same direction. So it is known as direct current. Okay, same idea utilized in electric motor. What you have studied earlier, same idea. Split rings used, they act as a commutator, reversing of current for first half cycle, second half cycle. Same idea used. Okay, so we can do some alteration in the system about R1 and R2 rings. Okay, instead of split rings we use split rings. They act as a commutator reversing the current for every half cycle, first half cycle and second half cycle. Even though ABCD is moving at clockwise direction, generated current in the coil, as you know, moving in same direction for first half cycle and second half cycle. If current is moving in same direction in external circuit, it is known as direct current. Short form of direct current is called DC. Okay, normally the application direct current is used to conduct electrical experiments in laboratory. Normal laboratory, high school, colleges, research lab, direct current is utilized. Okay, no need to transmit for a longer distance. Direct current is used to conduct electrical experiments in laboratory, science laboratories, very important. Okay, and major advantage already I explained to you while explaining AC. Once again I want to tell. Okay, so what are the differences between AC and DC? What are they? So here in alternating current alternates for every half cycle. But in direct current as you know won't alternate. Okay, first half cycle and second half cycle, generated current in the coil moving in same direction in external circuit. So it is known as direct current. Okay, so this is very important to understand. And alternating current can be transmitted for a longer distances from the powerhouse, from the generating center without loss of much energy. But direct current not possible to transmit like this for a longer distance. Okay, so that is the main advantage of AC. So all over India we are depending upon electrical energy. Electrical energy is the convenient form of energy to convert from one form to another form. Very convenient form of energy. Okay, so AC is utilized all over the country to function all the electrical devices. Okay, electrical devices, normally you know, no need to explain all those things. Majority gadgets are functioning by electricity. Okay, so you should know all these things. Okay, this is about actually, so AC and DC, merits of AC, advantages of AC over DC. So this is about, as you know, electric generator and how it is functioning. Majorly, after completion of explanation, you need to remember. What you have to remember? How will be question? Very important. Just see here. First part. What type of question may rise in exam on this topic? Okay, electric generator. Very important. Draw the neat labeled diagram of electric generator. Question number 1. Draw the neat labeled drawing of electric generator. You have to draw neatly the electric generator and you have to label all the parts. Number 1. And explain the working rule of electric generator with the principle. Okay, what is the principle of electric generator? You have to mention. Then you have to state along with how it is working. You have to explain. Okay, and how can you make alternating current, okay, system to direct current system in electric generator? Okay, normally we have here electric generator for AC. Okay, AC, how instead of alternating current in electric generator, how do you get direct current from the system? What alteration you do here? Okay, what is the role of commutator to get DC from electric generator? Okay, so like this many ideas you need to understand. Okay, same figure but ideas are different. Okay, which statement, which rule is used to run the electric generator? Fleming's right hand rule is used to run the electric generator. Fleming's right hand rule. You should know Fleming's right hand rule perfectly. The direction of 3 fingers. Okay, so like this, many questions. Question may be direct or indirect. Question may be direct or application type. You should be in a position to answer the question. Okay, only thing is you have to understand properly. If you understand properly the principle, construction and also the working rule of electric generator with respect to AC and DC, alternating current and DC, you can answer any type of question here. Okay, so that is important to note. Okay, next after this we directly go to last concept of this unit, magnetic effect of electric current. That is the thing called domestic electric circuit. First I draw domestic electric circuit, what we used to establish in our building. Okay, it may be home, school, colleges, shopping mall, okay, whatever it may be. So almost we follow the same circuit system, and majorly what are the components, electrical components fixed in various terminals, various points in the circuit. Okay, very easily we have to understand. Then you understand network, how electricity enter from electric line, transmission line to our building, and how it is functioning, how branches of circuit is spreading all over the building. Okay, it may be ground floor, first, second, third, all over the building. Branches of circuit. Okay, branches of circuit. Okay, let us see with the figure. Okay, that's the last concept of this unit, magnetic effect of electric current after electric generator. Okay, so first I am going to draw the domestic electric circuit. Domestic electric circuit. Side engine. Domestic electric circuit. Domestic electric circuits. Domestic electric circuits. Okay, very important to understand. Common domestic circuit. Okay, domestic electric circuits. So here first we going to draw, as you know, electric board's fuse. Electric board's fuse. Electric board's fuse. Electric board's fuse. Okay. Secondly, we going to draw electricity meter. Electricity meter. Thirdly, distribution box. Distribution box containing main switch and fuses. Distribution box. Okay. Distribution box which contain main switch, mains. Okay, mains plus fuses, various fuses. It contains mains and various fuses for each circuit. At the end, we go with the, as you know, various appliances in a room. Okay, if you consider like this, various appliances in a room. Okay, like this, we can take various appliances we can consider here. Okay. Likewise. Okay. First here. Secondly, we go with the likewise. So first live wire and neutral wire. So live wire, this is neutral wire. Live wire and neutral wire. Okay, live wire and neutral wire to understand. Okay, very important to note. Live wire and neutral wire. Okay. Live wire and neutral wire to understand. Okay, very important. Okay. Here, what we used to see. Okay, first of all, what we used to see, a live wire and neutral wire is separately moving here. You can understand. Then here we connect. Okay, here connected. Then once again, want to see. Okay, then after that, it's moving here. Okay. Then here 220 volts. See here, 220 volts. 220 volts. Okay. So now earth wire is moving like this. Earth wire is moving like this. Okay. Here once again. Here earth wire is moving, connected here. Earth wire is connected. Okay. So like this we have a live wire, neutral wire. Okay, live wire, neutral wire. One thing to understand. This is called earth wire. Third one. earth wire, earth wire. Okay, very important to understand earth wire. So now what you are observing, very important. So as I informed earlier, okay, here so distribution box, okay, distribution box, mains and fuses are connected. Okay, so live wire, neutral wire and earth wire, very important to understand. Okay, live wire, neutral wire and earth wire. Now see how to explain the domestic electric circuit. Domestic electric circuit. So normally, you know, in domestic purpose we are using many electrical devices. Many, okay, starting from, as you know, electric press, means electric iron box, okay, and you know, electric oven, okay, washing machine, refrigerator, okay, a mixer, grinder, table fan, okay, many equipments we use, toaster, okay, toaster, many equipments we use in our, as you know, system at home or other places. You have seen in the restaurant or kitchen or many appliances which are functioning by electricity. First, what you have to understand here is transmission line carrying electricity. One wire, if you see that, nearly 20,000 voltage flowing there, 20,000 volts. But as I informed, we need only 220 volts. 220 volts. Here you can write 220 volts. We need that much only. Okay, so 220 volts. Within this limit of potential, okay, potential difference, all our devices are functioning. 220 volts necessary to function all our devices. Very important to understand. And what I want to see here is, okay, three wires you have to measure the mainly you have to understand. First here, live wire. Live wire is in red color. Red color. Live wire. Okay, so live wire is in red color. See, observe correctly. Live wire is in red color, passing through electric board's fuse. Okay, then electric meter, then distribution box. Then for all the, as you know, rooms, all the rooms we call branch of a circuit, various rooms. Okay, then neutral wire. Neutral wire is in black color. Okay, so this is in red color. Neutral wire is in black color. Okay, black color. So the neutral wire is passing through electric board, then electric meter, then distribution box, and for all the rooms, for functioning of all the electrical devices. And third one, earth wire. Earth wire is in green color. Okay, earth wire is green in color. Earth wire is green in color. Earth wire is green in color. Earth wire green in color. Earth wire green in color. Okay, which, as you know, not connecting with this electric board or as in electric meter or distribution box, it is connected to all the home appliances, especially to metal body. For any leakage while functioning, any leakage of electricity while functioning the electrical device, so particular electricity move to earth grounding, by which we don't get major shock while handling any electrical devices which are having metal body. Okay, very important. We need to understand. Many electric oven, for example, okay, electric iron box, metal body. Okay, metal body. Okay, by leakage, grinder, sometime grinder having metal body. If any leakage of electricity through earth wire, green color wire, directly grounding takes place, then as you know, system is safe. Another one I want to tell, fuse. Okay, entry of the electric circuit means wire, transmission line to our building. Domestic circuit. Okay, domestic circuit. Entry level, first we have fuse. Electric board's fuse. Electric board's fuse. Okay, electric board's fuse. First transmission line, it may be underground cable or outside on the electric pole. Okay, anytime. Electricity enter our, for example, home or school or building. How? First entry to the electric board's fuse. Fuse is a safety device. If any excess of electricity by melting, fuse breaks the flow of electricity. Suppose excess of electricity enter through transmission line to our building. Then because of melting point, high melting point, it burns, then circuit breaks, further flow of electricity stops, then building is safe. Assets, people, or in other sector, animal, birds, correct? No, cattle shed, for example, electricity connected. If high flow means because of fuse, safety device, so further flow of electricity stops. High flow, high voltage flow. Otherwise, normally, as you know, electricity flow to all the appliances, all the rooms or branches of circuit. Very important. Okay, so first, as you know, live wire, it has two wire, live wire and neutral wire. Live wire red in color. Live wire carry positive charges. Electric current flow through live wire. Okay, charge, positive charge flow through live wire. Okay, live wire, electric current flow through live wire. Live wire first enter, as you know, electric board fuse, then it will enter the electric meter. Electric meter is the electrical device which measure, correct no? Which measure how much electricity consumed by the customer. Okay, per month we have to pay the amount for consumption of electricity in our building, in our home, shopping complex, restaurant, education establishment, correct no? So electric meter is the electrical device which recognize, which measure, okay, which give, as you know, data about, which give data about how much electricity consumed in a one particular period. Okay, very important. Electric meter, live wire enter electric meter. Finally, the distribution box. Distribution box carry main switch. If any problem in circuit, in any floor, in any room, okay, in any socket or device, we can off the main switch we can off in the distribution box. Then further flow of electricity stops. Then we can, as you know, we can stop the electrical hazards in any multi-story building, any floor or any room, and we can stop the damage of, as you know, casualty, damage of assets or any material. If you off the main switch, further flow of electricity stops. It is easy to repair, rectify the mistakes in the circuit. Okay, this is important. And fuses are the separate fuses for separate home appliance, separate fuses. Okay, for the safety of all the home appliances. Very important. This is distribution box. Live wire first enter this electric board, then very next electric meter, then distribution box, then various branches for various rooms and home appliances. And here neutral wire. Neutral wire is black in color. Okay, it is neutral in nature, and it is passing through first electric board, then it is for electric meter, then it is to distribution box, then for all the, as you know, home appliances in various rooms, branches of circuit, what we call, okay, various rooms, various branches of the circuit. Various home appliances we use. This is the first home appliance, the second home appliance. Means here actually this is nothing but sockets. You know already. We insert the 2-pin for television, 2-pin. Correct no? For electric induction coil, 2-pin. For example, refrigerator, 3-pin. Electric iron box, 3-pin. Grinder, 3-pin. Okay. 2-pin holders. 2-pin holders in the socket need less current. 3-pin holders need more current. They consume more current to function. Okay, electrical devices which have 3 pins in their holder, they need more energy, more electrical energy to function. Okay, you have seen grinder, refrigerator. Okay, many such electric iron box, 3 pin. You know all these things. Okay, so 3-pin consume more electricity from the circuit. Okay, and overloading in one socket we have to if we load, as you know, 2 or 3 2 pins or 2 3 pins, if we connect by other suppliers, other devices, then there will be overloading in particular point, overloading of the potential difference, potential energy. Overloading leads to electrical hazards. So according to the limit of the potential difference, according to the limit of the system, circuit system or the device socket, we have to insert the plugs, okay, or pins or devices. There should not be overloading. Okay, so after switch off only we have to remove the particular plug. Okay, if it is on, once again it may be danger. Okay, if switch is on, removing, drawing the plug or inserting the plug in the socket, all these things leads to electrical shock or electrical hazards. Okay, many precautions we have to take while handling such electrical device in home or various places. Okay, every year people die because of electrical shock, major shock. Very important. Okay, to recognize precautions we have to take. Okay, so consider precautions while handling such electrical devices or electric circuit, domestic electric circuits. Very important to understand. And neutral wire pass through the electric board and electric meter, distribution box and various home appliances in the rooms, in the various branches of electric circuit. And here last earth wire not passing through electric board or electric meter or distribution box. It is directly connected with all home appliances here. Then directly get into the earth. Okay, you have seen we dig the pit near the house and we fill the sand. Correct? No, we fill sand and charcoal. We draw the wire. Correct? No, so we insert the long earth wire. Earth wire normally is in green color. Okay, so why coloring here for 3 wires? To identify. Identification is important because if any problem in the circuit, electrician should repair this. So earth wire is in green color, live wire is in red color, and neutral wire is in black color. Okay, very important to understand. Earth wire is in green color, live wire is in red color. Okay, live wire is in red color, neutral wire is in black color. While repairing, one should understand the wire particularly. Then only we can connect the wire with particular device, electric board, fuse, electric meter, distribution box, and particular home appliances kept or fixed in various branches of the circuit or various rooms, various floors of a building. Okay, very important to understand all those things. Okay, and here electric fuse you know already. So lead and tin. Okay, the alloy is used to make fuse wire. Okay, fuse wire you can see here. It is kept in insulated system. Insulated here. This is a fuse here. You consider like this. So fuse wire is made up of lead and tin. Very thin, very small. It has as you know. Melting point. Okay, particular melting point is there. So excess of electricity, suppose it is more than 220, then because of melting point. Okay, because of melting point. Okay, so melting point, particular melting point. So flow of electricity burn this fuse wire, which is very important to understand. Okay, so here it has a low melting point. Low melting point. You have to understand it. Low melting point. Fuse wire has a low melting point. If a flow of current is beyond 220 volt, okay, it can't tolerate because of alloy. It is alloy, lead and tin mixer. It has low melting point. Okay, low melting point. So it burn. If burn, circuit breaks, it disconnect. Then further flow stops here. Okay, at the entrance of transmission line in our circuit, domestic wiring of circuit, we have electric board's fuse. Okay, very important. So when circuit breaks because of breaking of fuse wire, further flow stops. Other all devices safe, building safe, building people, everything safe. Okay, so first device we fix here. Okay, fixed here is electric fuse, electric board's fuse. Very important to understand. Okay, in domestic electric circuit, we need in all this sector for distribution of electricity in a systematic manner. Okay, distribution of electricity should be in a systematic manner. Okay, one important aspect you need to understand here, that is nothing but short circuit. Okay, so what is short circuit? What is overloading? Very important. Short circuit, one important term to understand. Short circuit, okay, short circuit and overloading. Overloading of electricity power. Short circuit or overloading, you need to understand. So what is overloading? What is overloading? When the electricity from transmission line enter our domestic wire more than 220 volts. More than 220 volts. That is called overloading. That is called overloading. The entry of potential difference. The entry of the potential difference entering our circuit more than 220 volts, that is called overloading. And similarly, suppose live wire and neutral wire touch each other, live wire and neutral wire touch each other, then, as you know, abruptly the quantity of electricity increasing in our domestic wiring. When they come in contact with each other, live wire and neutral wire, when the insulation of neutral wire or live wire eliminated, live wire and neutral wire insulation gone or other reason, okay, there is insulation for live wire and, as you know, neutral wire. When insulation, as you know, gone, then live wire come in contact with neutral wire or neutral wire come in contact with live wire, then abruptly the current, quantity of current increases in the, as you know, system, domestic wiring. That is called short circuit. Short circuit leads to many electrical hazards, casualties, okay, and burning of, as you know, system, okay, burning of various assets, okay, so death of people, domestic animals, etc. Okay, so when live wire come in contact with neutral wire, then the quantity of electricity abruptly increasing in the domestic wiring, then it is known as short circuiting. Short circuit leads to electrical hazards. It is very dangerous. By identifying, we have to eliminate, rectify the mistakes in the domestic wiring. And sometimes flow of electricity to our domestic wiring less than 220 volts. You have seen, if it is less than 220 volts, many of our gadgets, electrical gadgets are not functioning. We have to wait. There should be minimum electric energy to function our electrical gadgets. Even though there is step-up transformer in voltage guard, minimum electrical energy required to function. Otherwise, they spoil. Our electrical gadgets spoil if we run with the less than minimum energy. Very important. And sometimes more than 220 volts enter here because of fuse wire, safety device fuse wire, our system is safe. Otherwise, once again there will be problem in electric circuit. Okay, so these are the aspects you need to understand. Okay, so especially live wire function and neutral wire functioning, fuse wire functioning, and earth wire, how it is working, what is the advantage of earth wire in domestic wiring. And finally, you need to understand what is short circuit. Okay, when live wire come in contact with the neutral wire, so quantity of electricity abruptly increase in the system, domestic wiring, that leads to short circuit. Okay, then overloading means in particular point, as I informed earlier, so many devices inserting, that leads to generating spark, smoke, flame of fire, sometimes burst out. burst out of the system, switchboard devices, because overloading in particular point. So we have inserted many 2-pin, 3 pins or electrical devices for recharging or other purpose, functioning purpose, that leads to overloading in particular point, and that leads to electrical hazards. Okay, overloading means in particular point more than the limit potential difference generate, or as you know, devices we connect. Okay, all these terms, short circuiting, overloading, earth wire function, everything you need to understand under domestic electrical circuits. Okay, I stop here itself. We will see another concept in next unit. Thank you.